whilst honing out these holes, lapping out these holes to make them the correct diameter and more parallel. They're not perfect now, but they're a darn sight better. I have found that bore, when I put, well, this isn't the lifter, but when I put a lifter in the hole, this oiling band and that hole on the new lifters is higher, and when it's in there and at full lift, because there's such a big taper on the top of this bore, that oiling hole is only 3/4 of a millimeter covered at full lift, and I don't think that's enough. So the other ones are getting about 2 mil, and with the original one there's about 4. So the other one has lifted this oil band and that hole higher up this bore, because this one's been cut. Well, for whatever reason, it's a bit lower on the casting and it's been bored down. Makes it ever so tight. We're talking, it was 3/4 of a mil, which is 30 thou. Well, there's 25. That'll do. It's like that. That's how much it's covering that hole when that's, so the oil pressure, I'm not happy with it because it relies on the oil pressure coming up through. So I'm going to bore these out now, which is the next exercise, and put sleeves in, which brings me to this this contraption. Yeah, well, instead of taking that one off, this one here, not that piece, that is a single point cutter. This is pretty cutting. Oops, really pushing the engine off the bench. But you can see by all the swarf that's appearing, it is cutting, but it's still hard work. Basically, I've just got this, is the wrong way around, quarter drive, a 3/8 drive, driving this 1/2 inch to 3/8 with a 1/2 inch doodah, universal coupling. Stick that on there and go. There it is. You've got to push fairly firm. I might put the gears down. As you can see, this could take a day or two. Just made a small modification. Put a little oiling hole in the top of there, so I can just drop a little bit of oil onto this spindle. Right, after somewhat of a fashion, I have bored one hole. And it took longer than I thought, because right where that oiling hole is, there was a hard spot in the casting, and it played me up right down from the hole right down to the inner edge, right in here on the inner edge. But I had to get in there with a little grinder and grind out the hard piece of metal right down to near enough the final cut, and then I just put in the finishing boring bar, and that just cleaned it all up, so it's come up pretty good. So now I got the other 15 to go. This could take some time. I had to do a little modification. What happens is when the cutter breaks through to the oil well hole, in there. I don't know if I can get them out far enough. Breaks through to the oilway hole. It drops down into the oilway hole and causes a problem. So, because it's only got a single cutter, so that drops in the hole. So, to stop it doing that, I just knocked up this piece of scrap aluminium, and I've got this stop, which is just a bolt. So it can go up to that. You can turn it around a few times. I'm just trying it by hand at the moment. And then once that's clean, you can drop it in a little bit and it starts to cut again. And it's jamming, see? But it will stops it from just dropping straight in. So there is a problem, but I'm getting around the problems slowly. I've bored out this hole, and I made I've lost it now. Typical. Right, that's an inch test piece for a micrometer, but it actually reads about half a thou under. That, apart from the fact it's dirty, will go right in there. So I have made, and I've just put my hand on the darn thing and it's disappeared. There it is. That is another test piece. That is an inch. That there is an inch and a thou, and that is inch and 5/10. And the inch just goes in. The inch and a thou won't go. So that's it. So that's inch and a thou there. Inch and a half goes in. So I know it's inch and 5/10, and inch, that's the diameter it is, inch and a thou. So if I make that inch and 2 thou, it should be interference fit, or inch and 1.5 thou, and take it from there. That will be an interference fit for that tube. So that's that. But this one here I'm still working on. Well, the stop seems to be working a treat. So I can go up like that, give it half a turn, half a turn, and so forth, and work my way through. But it's actually doing pretty good, so I'll take it from there. Okay, finally bored out all of these lifter holes, ready to make sleeves to put in, to reline those holes, because they're all too short for the new lifters. Just dialing up the center of this fixture so I can slide a liner into there up to this shoulder, and there'll be a cross hole in it for the oilway hole that's in the block. But I've only made one. That's not finished. And so I've just dialed up that center mark, and that's near enough. It might move just a fraction, a couple tenths, but it's good enough. That's just you know, a wobbler, you know. There, job done. So obviously if it was out, that would be going in effect. Let's bugger that up. That would be going around like this if the centre was that far out, and the dial gauge would be going up and down. And the nearer you get to the centre, the less of a wobble you get, and your dial gauge doesn't move. So you can centre up that little pop mark. Beauty. I just realised I've got to take it out of here. I've got to draw another line for a datum line on the side. Oh. Right. Just took this out. I completely don't know where I put it took it out from. So now it's not in the middle. So I've got to zero that up. So I'll find a low spot or a low spot on one of them, which is there, and work from there. There. Back in centre. Bang on the money, that one. Nice one. Finished boring the hole. There's a shim in here, so if I take the shim out, it will clamp it up. But that is perfect. And now I've got to mark out a cross hole, the right distance down, is where the oil way hole will be. And then I can set that up over here and drill 16 holes all at the same time. Yep, I'm working to the new ISO pretty close tolerance. That'll do nicely, near enough, thereabouts, because the rest of the engine is near enough, thereabouts. That'll do nicely, because they didn't even drill a hole in the block halfway up and down that bore. It doesn't need to be. It's about 20 thou out of centre. So I'm going to do the same so that it's near enough when I push these in. If I put them in and then drilled back through the bore hole, I could do it, line them up. But I haven't got a drill bit or any means of doing it that's, I don't know, 2 foot long. And I can't be asked to make one. There. Okay, what I'm going to do is I've got super sharp scriber, and now I'm going to eyeball that crosshair with a magnifying glass. Because I don't have one of those old optical center functions. I'm just pressing it. Now I've just pressed the scriber on the spot, and by just pressing, I haven't made a massive dent. I've only made a very small mark, and now I can put that upright, and I ain't got a hammer. Give a little tap. If I eyeball that, eyeballing that, can't see it. I'll have another go. Well, that looks pretty good. And nope, it's not going to focus. Nope, doesn't like it. Maybe if I go like that. That's not looking shabby, is it? There. Beauty. Just checking my fantastic jig here, which doesn't work too bad actually. I want to make a better plate here so it's full width, but I haven't got around to it. I was doing it, but I had to put it back together again to make this part. Anyway, so just checking this is running parallel. I'm not interested in what number it's on, just that the needle is basically perfect. If it's only like 2/10 over that distance is nothing. So that's that. Right, just put that pointer in there just to give me a rough estimate of where it's to. And actually it's not too bad. So I can set that up vertically and horizontally. And actually that's pretty damn good. I'm going to leave it there. Bingo. Otherwise, I might have used that and got that running true
and then offered it up to the centre punch mark and then took it away, and if it deviated and started making this wiggle, after a bit of a faff, I've got that. We put it in the centre punch mark, take it out, and it doesn't make any difference. So I'm going to say that's bang on. I've cut 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 in there. Ah dear, so I've got several to go. Yeah, in old money, 7. Right, I fitted 1 sleeve, and as a test run to see how it went. That's a 1.5 thou interference fit, that one I aimed at. It might be slightly under that, but I've pulled it in with a bit of Loctite on it as well. But I put a cross hole in that, and the hole is 7/16, which is 11 point something, 1 or 2, and I put a 10mm cross hole in it. A little bit big, because as you're pulling it in, I did it with a threaded bar and pulled that in, and as I did it, it didn't matter what I did, it just kept wanting to rotate slightly, and it was very difficult to line it up. So in the end, I pulled it in halfway, and at the moment I got a small mark there, which was my alignment scratch. And the minute it started to turn, I stopped and I drove it, the rest of it in with a punch and a big hammer, and it went in really well, easy. And then the hole, I finished lining up the hole dead on with this very long drill bit, and it's a bit of drill rod or silver steel, and it's literally hand filed. Now I've bored all 16 tubes, I've got to turn the outside. So I've got this little fixture, and I'm going to do it between, in effect, between centres, a bit like between centres, and then I'm just going to bring up the tailstock. There. So that will now run between there, and I can turn the outside of that sleeve, and that's running pretty true. The diameter inside to the outside diameter will be, wow, I'm going to say bang on. Right, I'll just knock a bit of this material off on the outside. It'll probably slip actually. I'll just measure that, and then I want down to 100 and I want 1,000 of them. Whoops. Oh, that's because the stop's not released. Oh, hang on a minute. There we go. Right. I'm just going to put a little bit of coolant on here, just to make it mildly moist. And the idea is I'm just doing that to keep some of the dust down. Got this little jig set up in my fantastic vertical slide, and dial gauge this up so that it's running true. I was going to put a 10mm hole in, but that was a bit too nipping for when I'm trying to line this tube up in the block. So I'll put an 8mm hole, and then I'm going to clean the hole out with my other drill, so it'd be like an 8mm pilot hole. So that fits up against that shoulder. Just nip them up. Start that devil up. Bring this in here. Give off of that up to that for a moment. Do a couple of little touches, and it'll drill a hole. And once it's in, I've got that set up and stop there, so I can only go so far. Not that that really matters. Through. Job done. What I've got to do now is, with this tool, which I've just modified, is one of my boring bars. I'll put a bigger sleeve on there so that that sleeve will run in that hole. And this cutter I've wound out further, so that I'm machining it's about 40 thou shoulder on the top, and I've got to do that because I've made my sleeves with a small shoulder on. And there I've had to machine out that radius just there, and I don't know, a little bit there. It's just a little tiny bit, so I've got to go along all of these and just make sure, like for instance that, it's not going to fit down past that corner, so I've got to just knock off that corner and there, which is what this is doing. Right, just inserted one of these tubes with a bit of Loctite on it, and I'm aligning that hole with a piece of bar, like so. I'll take that out, and then put that little piece in the end, a big fat punch, hammer, I'm knocking it in. There. Now 1.5 thou interference fit in these holes. What I did to make these holes, or to size them, is I made a series of test pieces, and I put a number on. This is like 5 thou bigger than an inch, and then this one here was 6 thou, 4 thou, 2, I don't know what I've got on that one, 3, you know. Anyway, so what I did is that when I first started boring these holes out, I didn't quite get it right. These are all exactly the same, and these were slightly different. So what I've had to do is make these plugs so that if you can put the plug in the hole, can't get that one in, 2. I can't really get 2 in there either. It might go through with a hammer fit. This one here is the number 1, which means it's 1 thou bigger, and I've just knocked it in so far, and that's how hard they are to knock through. You've got to, it'll just go. Now that is how tight that 1 thou block, that's an inch and 1 thou. So the tube to go in that one is inch 2.5. So that one, that's an inch and a thou. That's an inch and 2.5 thou. Just put this one in. This is the 2.5 into the 1 thou over hole. Just lined it up. Put the little, that's not actually the right one, but that will do. And I'll see how tight this one is. With the hammer, that's going in. That one's quite good. Yeah. There. There. That is 2.5 thou interference fit on that already snug 1.5 thou interference fit, I should say, on that 1 thou over inch slug, which I had to hammer through. Right, now using this long drill I've made, I'm going to open out the 8mm pilot hole to the 7/16 that's required of this. Finished honing all these holes out to size now. I got this adjustable reamer to work, and it cut quite well. I'll just sneak the holes out with that, and finish them off with this, which is, that's a slight taper inside of there. So as you tighten that screw up, this opens this ring up slightly, and that's just a bit of wet and dry paper stuck on there with super glue, and it lasts quite a long time, and then you have to cut it off, put a new piece, but it does very well. And I've just gone up and down in here wherever needed with it on an electric drill, and then measured it using an internal dial gauge, and then every hole I'd recheck the setting on this and in between as well to make sure nothing had altered. So I don't know, what am I running at here? What does that say? That's 1.5. I'm anticipating that because steel is expansion rate is 0.0000012 per degree. Let's just say this is sitting here at 20 degrees and it grows and it gets another 100 degrees of temperature on it. That's going to take 2 noughts off that. It'll be 0.0012. That's actually 1.2 thou. So these could potentially grow 1.2 thou. I know this hole will grow as well, but what last thing I want is that to pinch up. So you run them too tight, I reckon they're going to pinch if you ain't careful, even on the flat tappet lifters, because I had these were too tight before. This side of the engine, there wasn't anything on here that was above 0.9 of a thou. So by the time these lifters grew a bit, they were fatter than the holes, and I think that's what the trouble was. They got hot when you gave it a bit of throttle, and they jammed up. This one jammed up, took the camshaft out. That's my shout. That's what I reckon happened. It wasn't that they were loose and weren't turning, they were tight and weren't turning. And this side, they were all about 1.3, 1.5 kind of touch, and they all span lovely. I never had any trouble out of them, but I had trouble with that one. That one wrecked the camshaft, and these here somewhere were always leaving a mark on the bottom of the flat tappet. On the bottom of a flat tappet. When there was a flat tap, it's disappeared. Oh, there he is. Yeah, so if that was a flat tappet, there was always a straight, faint line across there, where that was not rotating and the cam was always hitting in the same place. And it was in here somewhere. I can't quite remember where. And these are all tight. That one there was very tight. It was just like, almost like, oh, just these, ridiculous. These here will probably fall right through now, like that. That's how slack they are. But that is about 1.5 thou. 1.5 thou to 2 thou clearances. There. Which is right. Going back to the long drill. This is the long drill I used, and it was it's a piece, well, turned off there. It's a bit of 7/16 silver steel, and I just filed a drill bit end on it and just hardened it up. But prior to that one's long enough to reach. But prior to that, I made another one, but it ain't long enough. And that was just a bit of, don't know what steel, but you couldn't harden it, because I tried it. But I then got it red hot, so I made that drill exactly the same way, just filed it. But I used this compound stuff, and I put it in there 3 times. I put a little pot, a little tube full of it, and I just put that there, got that red hot, shoved it into this tube full of this compound and let it soak. and take it out, clean it off, got it red hot again. I did it 3 times, and then eventually I heated it up and quenched it off, and lo and behold, it was rock hard. To test this drill out, this carbonized drill that I made, case hardened one, I thought, yeah, it's rubbish. So I just chucked this bit of old scrap in the lathe, and yeah, it cut lovely. Aluminium, just to see if it would work. Actually, it makes quite a good fit, actually. It only opens it out to exactly that diameter. So I thought, will it cut steel? Yes. I cut that hole with, oops, this homemade case hardened drill. I don't know if it's how deep it is, but it's a very good fit hole. It's quite nice. It's like almost a D-bit reamer type of thing. So I just put plenty of coolant on it, and afterwards, after drilling that, I thought I'd be wrecked, but it isn't. The corners are in still good shape. So the case hardening must be quite deep. Must be reasonable amount on there. Otherwise, it would have just, with the heat of that, it would have just burnt that out. But it worked.